Hello, we are going to review the empirical rule worksheet solutions. The first two questions just reinforce what that 68, 95, 99, 7% rule, and then we work through the rest of the document using that rule to help us solve problems. Given an approximately normal distribution, what percentage of all values are within one standard deviation? That is 68%. 95% falls within 2 and 99.7% falls within 3 standard deviations of the mean. We then used that to determine the specific percentages that were in the various drawings that we're going to do. When you take 68% and you cut that in half, you get 34% on either side. And then when you have 95% cut in half, and you've already accounted for 34. Remember, we got 13.5% on either side here. And then we had 2.35% and 0.15%. And we developed those in class. And those stay the same for each of the problems. I will label them for each problem. When we are labeling based on given information, we're told that we have a mean of 175 and a standard deviation of 37. We put our mean at the bottom of the number line, and then we add our standard deviation to the right and subtract to the left. So this would be, each distance is 37. So we take 175 plus 37 to get 212. Plus 37 gives you 249. Plus 37 gives you 286. And then 175 minus 37 gives you 138. Minus 37 is 101, and minus 37 is 64. Put the mean in the middle, and then you use your standard deviation to create the rest of the values in your number line. When I'm asked for the values, what percentage is between 138 and 212? That is one standard deviation. That's going to be 68%. Between 101 to 249, that's two standard deviations, which is 95%. And then between 64 to 286, that's three standard deviations, which is 99.7%. The next question asks us what percent is outside the interval. Well, if we knew that 68% is inside the interval, then the remainder is 100 minus that 68, which leaves us with 32%. You could also add up on the outside of the orange the 0.15, the 2.35, 13.5 on both sides. That's going to be 32%. Same thing with 101 to 249. If 95% is inside, that means there's 5% outside. And for our 64 to 286, if 99.7% are inside, then that's 0.3% outside. Moving on to the next question, we're going to use those same percentages. 34%, 13.5%, 2.35%, and 0.15% on either side. And then we put our mean in the middle, and we use our standard deviation to calculate our new values. 122 plus 22 is 144, plus 22 is 166, plus 22 is 188. Minus 22 is 100, minus 22 is 78, minus 22 is 56. We're asked for 68% of the values. That's one standard deviation. One standard deviation goes from 100 to 144. And we write two parentheses with a comma in between. 95% is two standard deviations. That's the interval 78 to 166. And then 99.7 is three standard deviations, which is the interval 56 to 188. The next question says, what percent of values are above 122? 122 is right in the middle, and above is to the right, which means we would be adding the percents 34, 13.5, 2.35, and 0.15 to get 50%. And then below 78, I go to 78, and I'm adding all the values below that, which is 2.35, and 0.15, which gives us 2.5%. Same approach for question 6. We have a new mean and standard deviation. The mean is 159, the standard deviation is 17. Same percentages. Putting the mean in the middle, adding the standard deviation of 17, I get 176, 193, 210. To the left, subtracting, I get 142, 125, and 108. The interval of 142 to 176, that's one standard deviation, which is 68%. The interval from 125 up to 193, that's two standard deviations, which is 95%. On the next page are the next questions. I'm going to go ahead and answer them here with our drawing. The next question says, what interval contains 99.7%? So 99.7% is 3 standard deviations, which is going to be from 108 to 210. Question E says, what percent of values are above 176? So I go to 176 and I go to the right and I add those values. That's 13.5% plus 2.35% plus 0.15%, which is 16%. And then the last question asks me what values are below 125. I go to 125 and I'm adding all the values below that, which would be 2.35% plus 0.15% to give me 2.5%. Here are those answers reflected on this piece of paper. Now we're getting into a problem that actually gives us context, not just numbers. We're talking about women's heights, college women. We have a mean of 65 inches and a standard deviation of 2.5 inches. Our percentages do not change. 34% in the middle, 13.5%, 2.35%, and 0.15%. Remember that it is critical to have the percent symbol listed, otherwise your decimal answer is wrong, because 0.15% is equal to 0.0015. So if you just wrote 0.15 without the percent symbol, it's a very different number. Okay, now we're asked, we have 65 for our average, adding 2.5, we get 67.5, 70, and 72.5. Subtracting gives 62.5, 60, and 57.5. We're looking for taller than 65 inches. That's the halfway mark, so that's going to give us 50% when you add all of those values. Shorter than 65, same thing, that's the halfway mark. It's also going to be 50% when you add those percentages, 34, 13.5, 2.35, and 0.15. What percentage are between 62.5 and 67.5? That's one standard deviation each way, that's 68%. From 60 to 70, that's going to give us 95%, that's two standard deviations. And here is where we're getting to something different. 60 to 67.5, so that's not your standard range. That is 13.5% plus 34% plus 34%, which is 81.5%. The others are like your 1, 2, or 3 standard deviations. This one is a different range. What percent is shorter than 70? I'm going to add all of those values below. That's going to give me, I've got 0.15% plus 2.35%. Plus 13.5%, plus 34%, plus 34%, plus 13.5%, and we get 97.5% here. Now this last question asks us about a percentile, so it's asking you where a percentile will be located, and something you need to know about a percentile is from a value below. So if we have some measurement in our graph, I'm talking about this area here, and then this would be the, whatever the area is, so this is the value, and whatever the area is would be the percentile. So if or whatever your probability, so the area is also your probability. So if we have 34%, it'd be the 34th percentile. If we have 50%, it'd be the 50th percentile. Looking at our chart, when I'm looking for the 50th percentile, that means that I need to figure out what number has 50% below it. So if this is 50% here, what is this value here? Well, we know based on the empirical rule that from the middle down is 50%, and that's the value of 65 inches. Now, the second one is asking us for the 97th percentile because we can't have a 97.5 percentile, you just have 97. So we're looking for 97% below, which would give us roughly 70. So if you go up to 70 on your chart and you were to find the area below 70, you would get 97.5, which is reference from question F. And then that 50% was B. So this would be the 50th percentile. And this would be the 97th percentile. And percentiles are always from that value down. Last question, we're asked to actually calculate a number of chicks, not just a percentage. I'm going to fill in my percents as I do. 34%, 13.5%, 2.35%, 0.15%. Same thing for this side. And then I'm going to use my values. I'm told that the mean is 21 days and the standard deviation is 1 day, which means I put 21 in the middle and then I add 1 to the right and I subtract 1 to go to the left. And then it says, if 1,000 eggs are being incubated, how many do you expect to hatch? This is giving you, based on a probability, you're trying to find a percentage of a number. And to find the percentage of a number, you take that number times the percent as a decimal. First, I have to figure out what's the probability of being from 19 to 23 days. So 19 to 23 is going to give me 13.5 plus 34 plus 34 plus 13.5. That's 2 standard deviations, so that's 95%. So we need to find 95% of 1,000. So we turn the percent to a decimal and we multiply by 1,000 and we get 950 chicks. 22 days or more, I go to 22 and I need to find out what that probability is. I add 13.5 plus 2.35 plus 0.15 to get 16%. And that means I need to calculate 16% of 1,000. Which is 160 chicks. Next, I'm going 21 days or fewer. We know that that's our halfway mark, which is 50%. I need to find 50% of 1,000. Turn that into a decimal. Half of 1,000 is 500. The next question asks us between 18 to 21 days. Here's 18 up to 21. We're going to add 34, 13.5, and 2.35 to get 49.85, which means I need to find 49.85% of 1,000, turn that into a decimal, multiply it by 1,000, and I get 498.5 chicks. You cannot have half a chick. But when you are calculating expected value, it is actually okay to say half a chick. When you're dealing with, you'll hear people talk about the American dream, where there's 2.5 kids. It's an expected value. You can't actually have 2.5 children, but when you're calculating expected value, it is okay. Okay, 19 days or fewer. I go to 19 and I add the values down. 2.35 and 0.15 is 2.5. Calculating 2.5% of 1,000. Convert this to a decimal. If you're not sure how to convert a percent to a decimal, you divide by 100 and drop the percent sign. And we have 25 chicks here. Next question is 19 to 24. 19 to 24, which means I'm adding 13.5, 34, 34, 13.5, and 2.35. That gives you 97.35. And we need to calculate 97.35% of 1,000. Turn that into a decimal and multiply, and we're going to get 973.5 chicks. Again, expected value, that's okay. The next one is 18 to 24. I'm going to make this 18 all the way to 24 is 3 standard deviations, which we know is 99.7%. Calculating 99.7% of 1,000 means we turn that into a decimal, multiply by 1,000, I get 997 chicks. And then our last question is 18 days or more. So not just 18 to 24, but 18 and higher. So it's off by just a small amount. 18 or higher starts at this value and goes all the way to the right, which means it's everything but that 0.15%. Add 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15, and we get 99.85%, excuse me, of 1,000. Turn that into a decimal, multiply it by 1,000, I get 998.5 chicks. That's it for this assignment.